Whether it's the uncomfortably hot days of summer, or the cold and icy winter days, the heating and air conditioning systems are an important part of our daily lives. There are natural ways to cool down or warm up, but the heating and cooling systems have achieved considerable success in keeping us at equilibrium, and this in turn has enabled us go about our daily activities comfortably. HVAC stands for heating, ventilation, and air conditioning. The HVAC system is the technology, equipment, and processes that go into heating, ventilating and cooling a commercial or residential property. Heating, ventilation, and air conditioning systems are something that most of us don't understand very well. During summer, we turn on the switch and we expect cool air to flow in through the vents, and during winter we expect warm air to flow in. A comfortable temperature is important in both residential and commercial buildings. Heating and cooling systems are important for maintaining a comfortable temperature, by circulating the required form of air in an environment. But the big question is, how do these systems actually work? Control devices or systems have three basic components, and these are: first, a source of warmed or cooled air. Second, a system of distributing the air. Third, a control otherwise known as the thermostat used to regulate the system. A furnace can be a source of warm air, and an air conditioner can be a source of cool air. Heating and cooling systems function through a process, whereby air is circulated through a series of ducts. This air is cooled or heated, depending on the season, and made to circulate back into the room. In buildings with a central cooling or heating system, the cold air and the hot air most times flow through the same distribution path. The thermostat allows you to regulate the temperature of your home, and it can let the system automatically adjust the temperature as needed. Most heating and cooling systems possess both heating coils and cooling coils. Like the name implies, the heating coil's function is to heat the air, while the cooling coil's function is to cool the air. There is also a system for humidity control. There are basically three types of heating and cooling systems. First, central air conditioner. Second, window air conditioner. Third, room heating and cooling system. The central air conditioning systems use ducts to distribute air throughout the house. They are the most common type of heating and cooling systems. Room heating and cooling systems are used in much smaller spaces, like in small apartments or condos. Window heating and cooling systems are installed in the window frame of homes. These three types of heating and cooling system basically operate by the same principle of exchanging heat with the surrounding environment. During summer, heat is removed from the home, and during winter, heat is added to the home. Central AC systems are well suited for large homes, while a room heating and cooling system can be used for small homes. Window AC systems are used in warmer climates. Heating and cooling systems burn fuel. While most home heating systems use gas or fuel oil, other systems use electricity. When the furnace is turned on, it uses the fuel that powers it. Burning of the fuel creates heat which is channeled through ducts and is then blown out of vents, registers, radiators, or heating panels. Older heating and cooling systems use boilers to store and heat water, which is then circulated through pipes covered in the wall, floor, or ceiling, thereby heating the home. Electrical power is used to cool a gas in a coil to its liquid state in air conditioners. Warm air is cooled by contacting the cooling coil, and this cooled air is channeled to the rooms of your home through ducts, and it comes out through registers, or in the case of room air conditioners, directly from the unit itself. In terms of heating, most homes have furnaces. As said earlier, the furnaces can use different heat sources to generate heat, such as electricity, natural gas, propane, or fuel oil. With respect to cooling, a HVAC system will usually have an air conditioner or heat pump. An air conditioner only cools, but the heat pump can both heat and cool a home. The refrigerant is key to heat absorption in cooling systems. The refrigerant has high latent heat of vaporization. The refrigerant can take heat from its surrounding to evaporate. Now, let's talk about air-to-air heat pumps. Air-to-air heat pumps are similar to split-unit air conditioners. They can both heat and cool by making use of a reversing valve. The basic parts of an air-to-air heat pump includes compressor, reversing valve, indoor heat exchanger, expansion valve, non-return valve, bidirectional filter dryer, sight glass, expansion valve, non-return valve, controller, outdoor heat exchanger. Let's look at how the heat pump works during cooling. During cooling, the air-to-air heat pump acts like a normal air conditioner. When the system is set at cool mode, the compressor forces the high temperature, high pressure, superheated refrigerant vapor through the reversing valve, which transfers it to the outdoor heat exchanger. The fan of the outdoor unit blows ambient air across the refrigerant coil, so it carries away the heat of the refrigerant. The refrigerant condenses to liquid, having lost most of its energy. The outdoor unit is considered as a condenser, since it condenses the superheated refrigerant to low temperature, low pressure liquid. The refrigerant leaves as a slightly cooled liquid, and moves through the non-return valve, then the sight glass, and then the filter dryer. The next non-return valve is closed, therefore, the refrigerant passes through the expansion valve. There is a section in the expansion valve with a small diameter. When the refrigerant passes through this small diameter region, it splits into numerous pieces, which causes a pressure and temperature drop. The refrigerant leaves the expansion valve as a low temperature, low pressure, liquid vapor mixture. It then flows into the indoor heat exchanger, where the fan blows the warm indoor air over the coil, which causes the refrigerant to absorb heat from the air. The air that lost heat becomes cooler, and cooler breeze comes out from the front of the indoor heat exchanger, circulating round the room. The refrigerant boils and takes the heat away. The refrigerant leaves the indoor heat exchanger in a low pressure, low temperature, slightly superheated state, and flows into the reversing valve, which takes it into the compressor, and the cycle repeats. The indoor heat exchanger can be considered as an evaporator, since the refrigerant absorbs the heat in the room, and evaporates to a low pressure, low temperature, superheated state. Now, let's look at how the air-to-air heat pump functions during heating. If the system is set to heat mode, the refrigerant leaves the compressor as a high pressure, high temperature, superheated vapor. It passes through the reversing valve. The refrigerant heads to the indoor heat exchanger, and cool air in the room is blown over the refrigerant bearing coil. The refrigerant loses its heat to the room, and condenses into a liquid. It leaves as a high pressure, slightly cooled liquid. The refrigerant then comes to the expansion valve, but since the expansion valve is closed, it passes through the non-return valve. Then through the filter dryer, and then the sight glass, and through the second expansion valve, since the non-return valve is preventing flow in that direction. As it passes through the expansion valve, it turns into a low temperature, low pressure, liquid vapor mixture. As the volume increases, it then moves to the outdoor heat exchanger, where a fan blows ambient air, adding heat to the cool refrigerant. The refrigerant boils at a very low temperature. As it boils, it leaves the outdoor heat exchanger as a low pressure, low temperature, slightly supersaturated vapor, and heads to the reversing valve, which directs it to the compressor. What are the controls for heating and cooling systems? A thermostat is a heat-sensitive switch that acts as the basic control for regulating the temperature of a home. It responds to changes in the temperature of the air where it is located, and turns the furnace, or air conditioner on, or off, to maintain the temperature at a set level, called the set point. The key component of the thermostat is a bimetallic element that expands or contracts as the temperature increases or decreases in a house. How to maintain your HVAC system? One way to maintain the HVAC system is by changing its air filter regularly. This will prevent it from getting clogged and ensure it runs efficiently. The coils should also be cleaned once every few months. Another way to care for the HVAC system is by ensuring the thermostat is set at a comfortable temperature. It shouldn't be raised or lowered by more than 5 degrees at a time. Finally, the benefits of having an HVAC system. The HVAC system makes a home or a commercial building comfortable. It improves the quality of air in a home. And it also helps to prolong the life of appliances.